by introduction. I've been working with customers since we started and went live in GA with Oracle Database at Azure, which will be coming up here soon on 2 years ago. I have been able to work with dozens of customers implementing these solutions across all 3 of these cloud providers. And so, like I said, as we get in there, I'll try and interject some different experiences and things that I've had. Definitely welcome your input and your questions as well. The last thing we'll do here then also is try and touch a little bit on the architecture, and I would love to even just jump into some of the consoles here and be able to show y'all what this looks like when we talk about using Oracle Database Services in these different cloud providers. So that is what we're planning here for the next about an hour and 25 minutes, I think. So, all right. To kind of get started here, multi-cloud, right, means different things, right, to different people and the perspective that you're coming from. So in general, if we take multi-cloud just meaning that you use more than one of the public cloud providers, the cloud service providers, right, the hyperscalers as we call them, you would be in a multi-cloud scenario, right? And what we know and a study published here within the recent years from SAP is that 98% of companies are already using more than one cloud provider. Probably not surprising. Many of y'all probably have more than one cloud provider in your organizations. And there are a lot of different reasons why that is, right? Similar to if you and your company is not cloud native or born in the cloud, right? You've been around longer. You likely have workloads that have been or very likely still sitting in on-premise data centers, and in those locations, right? You didn't pick one provider for the different technology you had, right? You picked multiple, and a lot of that came from the same reasons. You're looking to get best of breed technologies. You want to optimize costs. You don't want to, right, put too many of your eggs in one basket, if you will. Some of those same reasons are coming up on why the organizations are forming relationships, strategic partnerships with more than one cloud provider here. It also provides agility, right? Each provider offers a different set of native services, and they have their strengths and weaknesses. There's concerns around lock-in, potentially concerns around data residency. But for all of these reasons, right, on why companies are using more than one cloud, there's still, right, the challenge around doing so. Things around operationalizing across those and managing across those cloud providers can be a challenge because they're each different, a little bit unique in their own way. The governance around the data, security becomes a big thing, and getting those security certifications across multiple clouds. Things like networking always come up, especially in multi-cloud scenarios. How do we interconnect those networking and the latency and things around it? So these become challenges and may very likely be a reason why, as we kind of look at the use of multiple clouds, why here 31% of enterprise workloads, or only 31%, right, are actually running inside the cloud, right? Many and most of these workloads still are sitting on premise. Even now, I mean, we're coming up on 20 years, right, since AWS really started and became, and offering the first workloads that you could move into a cloud provider. So as Oracle, right, we started looking at this and really realizing that really what you're looking for, how great would it be to be able to run services, native cloud services from one cloud provider, but be able to choose which cloud you want to run those in. Right? You want the best of both worlds. And when it comes to our technology specifically, right, the Oracle database technology, being able to to run those services and not just running Oracle databases, right? You could run Oracle databases just software. You could run that on the compute of any one of these cloud providers, and many organizations, maybe yours, have done that, right? Running that inside of AWS and Azure and Google Cloud. However, you lose a lot of what can be available to you from an actual cloud service, right? Running that technology in a database. So as we kind of looked at this potential challenge, and I'll even mention, like, from my perspective, I've had a number of different roles at Oracle. One of my prior roles was within the product management organization over the Exadata cloud services. So that's our Exadata service that's running inside of OCI, as well as what we call our Cloud at Customer offering. And for a number of years, as we had the service, I was sitting with different organizations, and remember many conversations in different conference rooms where we would talk about what the service had to offer to meet the use cases and requirements of the customer. And what I would hear back is, look, we don't, we are good with the Exadata technology. We've run it, we trust it. When are you going to let us run this in AWS, right? When are you going to let us run this in Azure? And heard this, time and time again. And kind of fast forward a little while, and I had left Oracle for some time and went and worked with another organization where I got to work with all of the different cloud providers and non-Oracle technology. Saw kind of a different side, but when Oracle announced this solution with Oracle database at Azure, I knew how well received it would be, and it's really what drove me essentially to come back to Oracle and be part of this. And definitely over the last couple of years now, definitely have seen that, and some of the use cases we'll talk about here on the way it can help. But one of the unique things of what we're doing with Multicloud then here is this is actually embedding, like I mentioned, a little of one cloud and the services inside of the others. So when we talk about now the Oracle database services, the services that you have, for years been able to get with inside of OCI, which is Oracle Cloud Infrastructure, those same services now can be deployed in the cloud provider of your choice. And by the way this has actually been done, and we'll kind of jump into the architecture here in a bit, but is actually taking a bit of OCI and putting it inside the regions, the data centers of these other cloud providers. That way, right, we can manage that full stack and offer, we'll kind of touch more on some of these use cases, but essentially, right, something different here is those services, like an Exadata service, right, can be deployed inside of AWS, inside of Google Cloud, inside of Azure, running in the data centers of those cloud hyperscalers. However, being on, right, Oracle managed infrastructure. So in order to deploy that full cloud service of an Exadata database service or of an autonomous database service, Oracle needs to be able to manage the full stack, right? And this is where things are a little bit unique. Sometimes I get asked, hey, like, what's the difference here between something like what Databricks is doing or what Snowflake is doing? And the answer to that is those services, right, third-party services that you deploy through the marketplace and these different cloud providers, essentially take their software. And I used to work for one of these organizations, right? We would take our software and deploy it on the compute, the infrastructure, the IaaS services of these different cloud providers. And then we'd package and make a service around that, right? Managed service that then you could deploy. And now, Databricks or Snowflake can run in any of these clouds, right? Or other services that you may be familiar with. And in this case, again, and why we call this kind of a multi-cloud solution, is we've taken a little bit of OCI and embedded in these so that we can actually manage the full stack of that. That's how you can get the unique capabilities of the Exadata database service running on an Exadata infrastructure inside these cloud providers of choice. Being able to still have the experience of being, deploying these with the hyperscaler APIs, right, inside the hyperscaler's network, VPCs or VNets, to be able to provide that connectivity with low latency to the different services that your applications are running on within these. So that kind of at a high level is what the service is. And we'll kind of talk a little bit about the history, but as we kind of get there, maybe what I will do is pause here for a second. Like I said, feel free to put your questions in chat, raise your hand, and you could even unmute, and we can talk if there are any questions. So, any questions so far? All right, I'll continue. All right, so
I would chime in and say,
yeah.
everyone, let's be interactive. We just wanted this to be a interactive session with a lot of value rather than just one-way webinar. So
Good. Thanks, Sudhir. And yeah, and we'll have time as we kind of get in it, maybe more interactions here. So as we kind of look at the history here, right? The whole idea of what we're doing from a multi-cloud, right, and setting up the partnerships between Oracle and the other cloud service providers didn't even just start like a couple years ago when I mentioned with database at Azure. But actually, if you go back all the way to 2019, we first really started that partnership with Microsoft and deciding like, hey, we've got a lot of customers that use services, right, in both of our clouds. Why don't we make it a little easier for them to interconnect, right, to connect those clouds from a networking standpoint, right? So many of y'all that may be, running workloads in multiple clouds, probably use third-party providers, right? And there are some that have become very specialized in this that can provide that kind of central hub location from a network connectivity standpoint, right, to then connect into to multiple cloud providers. What Microsoft and Oracle did back in 2019 was say, we'll without having any kind of third-party provider, we'll interconnect both of those clouds and provide that more as a service so that you can take advantage of that dedicated, more private network and that linking between our clouds directly, right? And that's what we started with, and that service is still available today, and still has certain use cases. We kind of expanded that as we went and offered our first technology with our MySQL HeatWave service on AWS. But then we fast forward, and this is where we get to the Oracle database services available with Oracle database at Azure, with Google, including the Google Interconnect, but also Oracle database at Google Cloud, and now just most recently, right, with the GA of Oracle database at AWS. Just about 6 weeks ago. What we've been doing is expanding our regional footprint with each of these providers. You'll see that we've got a number of regions at this point with Azure. I think there's, and I don't even know what the count is. I've lost track. 20-something regions with Azure. Still more planned, as well as these other providers. I often get asked as well, like, well, did you just did you just build out your services and using the interconnect? And no, right? So the database at Azure, database at GCP, and at AWS, right, are actually, as we'll look into the architecture, that do not utilize the interconnect. Instead, they're services that are, actually deployed inside of the data centers of the different cloud providers. That said, there may be use cases where the interconnect still comes into play. And so, you have the choice of the different solutions that we provide from that multi-cloud perspective.
yes, I have one question.
Yeah.
How does this different from the RDS service that is offered by cloud service providers?
Yeah. So good question, right? And so this is something will probably come up and when we talk about AWS. So AWS is a little bit unique from the others, from Azure or Google Cloud, in the fact that AWS offered a managed service, right, around the Oracle database, and packaged that so it wasn't just deploying Oracle database software on the compute, right, that I'd mentioned before, but AWS will actually manage RDS. And so as we can get in and we'll talk about some of the key benefits and use cases here, and we can kind of bring RDS into that. I mean, RDS is still definitely a valid and legitimate service, and we've got lots, there's lots of customers, AWS and Oracle customers that utilize RDS. I would say one of the key differences there is RDS, right? RDS 1 is still a service where even though it's managed by AWS, it's still just deploying the Oracle database software on general commodity infrastructure. Essentially, it's on kind of EC2, but they package it, right, as a managed service and then deploy that as RDS so that AWS manages a lot of that service. And depending on if you do regular RDS or RDS custom, kind of changes that management model a little bit. When I get into the different services that we offer here for Oracle Database at AWS, these services run on Oracle managed infrastructure, right? Including services on Exadata infrastructure. This provides ability of doing things from a performance and availability standpoint that isn't available to RDS just based on the infrastructure that it runs on, right? And that includes things like Exadata, like RAC, right? Real application clusters, and those that run Oracle databases know that and the advantages of the high availability and things that can be provided, and it's offered that as a service. So that'd be one kind of key difference. Does that help, Sudhir?
It is helpful. Thank you.
Mm-hmm. Thanks. All right. So one of the things I want to make sure is understood here is when we talk about the services that Oracle offering, when we have these Oracle database services inside our cloud service provider partners, this isn't new services. We didn't create anything new from a service standpoint here. We are just offering choice on the deployment model, right? So the same services and those that of you that may have either evaluated or are using Oracle Cloud Infrastructure right here, and the different database services that that can be deployed both. We'll talk a little bit more about these, but either from a co-managed or an autonomous model, right? That you can deploy in OCI, or that you can deploy in our OCI in your data center called Cloud at Customer. Those are the exact same services here then from a multi-cloud standpoint, right, that we're deploying within the other cloud providers. Same service, different deployment model.
And
all right.
Kasey, there's a question here from Rocky. He's asking, do you have any metrics for Oracle DB running on RDS and Exadata?
Yeah, so metrics, and I don't know, Rocky, maybe, I don't know if you're talking like performance, like comparisons or benchmarks or those types of things, or what is meant by metrics, but definitely we could get in and kind of talk more in detail on some of the things between RDS and Exadata. There are, I mean, we've got some things to offer. We don't generally publish per se benchmarks because there's so many different variables into that. But we do have some comparisons that we could definitely share. I don't have anything probably to share specifically today. But yeah, definitely, like if we can definitely reach out and maybe have a conversation offline. So I'll share my contact information and definitely let's talk a little bit more.
Yeah, so he says, yes, performance metrics and comparisons. So probably the technical comparisons, Kasey.
Yeah, perfect.
Yeah.
And definitely we can definitely get into that. I mean, one thing I'll mention, we won't dive deeply into the benefits and all of the things of Exadata. A little bit we'll talk about today. I'll try and highlight some of the things with RDS and comparisons specifically as you make kind of that evaluation. But definitely there are some advantages from a performance and availability standpoint, as I mentioned. So good, thanks, good question. All right. Touch on, I'm not going to spend a lot of time on different customers, but I'll probably interject some of my stories, as well as we do have some customers who have agreed to make statements publicly or be public references. 3 of those here on the slide kind of showcase some of the things we're doing across each different cloud provider. State Street, Definitely, State Street is a good example in that they are using here. This is talking about AWS and Oracle, and they were actually Andy Zitney from State Street was actually on stage with our Oracle Cloud World last year, talking about what they're doing with both AWS and Oracle and using Oracle database at AWS. One of the first customers there with AWS, but they also use other cloud providers and the service with others. So they're a good example of kind of Oracle, the Oracle services and OCI becoming like a hub into being able to deploy the Oracle database and the database services in a variety of different clouds, right? Not just even AWS or OCI, but other cloud providers as well. Conduent, and also an early adopter of Oracle database at Azure, fully in production at this point. Conduent, big, large service provider, they develop the tolling system for the New York Transit Authority. This is an example, again, in kind of a multi-cloud use case where Conduent, they leverage a lot of like workloads in OCI. They also have a lot deployed in Azure. They use various SaaS applications and Oracle, including the Oracle, some back office application using the Oracle Fusion apps. These require tight integrations. The tolling app specifically, right? They initially kind of had looked at maybe a split stack type architecture, but ultimately the Oracle database at Azure led them to be able to, kind of reunite that application and the database into Azure specifically to reduce those latencies and make that possible. And they're finally able to make that workload work by being able to bring the Oracle database into Azure with these services. And then Dun & Bradstreet, another example there with Google Cloud. Lots of companies use Google Cloud, right, for the analytics and AI tools, and being able to unite like the data that is already sitting in Oracle databases and bring that into the Google Cloud, right, to be able to use with those AI and analytic tools in Google Cloud was key for their use case. But one of the things I'll just mention anecdotally as well, so I deal with a lot of customers in the healthcare industry. Just yesterday, I was in a meeting with kind of a steering committee meeting for a project we have for database at Azure with this customer. They are in the process of migrating all of their workloads into Oracle database at Azure. They had initially deployed many different databases in Azure on Azure Compute. We're struggling with availability, right? They've done lots of things to try and get more HA capabilities on Azure Compute, using things like Data Guard and setting up fast start failover stuff and architecture and things that they could do, but it was always a challenge and a pain point for them, as well as getting the performance they needed. Database at Azure has totally changed that for them. And it's interesting because they just got started like 2 months ago. They've already deployed 4 different databases, so they just started migrating databases last week. They had 2 last week, 2 this week, and the comment from their leadership was, "We can't believe how simple this has been. Like from the start, that project, getting everything built up on the landing zone in Azure and the things in OCI." And being able to bring this and like be migrating workloads, and now they're gonna, their plan is, to do 2 a week, and that's just because the app teams can't really support doing more than that or faster than that, but they've done it very quickly, seamlessly, without really any problems. And so, and they were just amazed, and that, and also kind of the business case that was done for them, and how they were able to do this and actually are saving money compared to all of that they deployed and tried to be when they were trying to do it on their own, just on Azure Compute. So lots of different customers and different examples of the way things are going here for customers. All right, so now I'm going to jump into kind of the different services, right, that are available in our Oracle database at the different hyperscalers and like cloud. So primarily, we've got three different service offerings, and those of you that have looked into the services available in OCI will be familiar with these. Like I mentioned, just a different deployment model. But the autonomous, the autonomous database service is our fully managed cloud service. If you're looking for a, database as a service, for cloud native type workloads, the autonomous database is where you'd want to go. This still, Autonomous still runs on Exadata, but automates, all of the like system level DBA aspects as well as the infrastructure. So this can really help and drive lowering, the TCO and the automation. That said, it comes potentially at the expense of a little bit less control, right? And so, I mean, one of the questions was talked about RDS, for example. Autonomous database can be compared a little bit more similarly to RDS, in the nature of what's managed for you. Even though we've got a few more things that would automate even up through some of the performance tuning and indexing, and there's even some more things that are available that you wouldn't be able to get out of RDS. Now we look at the Exadata database service, right? Also runs on Exadata. We call this a co-managed service because we provide a higher level of administrative control, and I'll talk a little bit more about this. This is something that's often used for workloads where you're just going to lift and shift. Everything's going to kind of stay the same. You're looking for something to just get there faster, and get into the cloud faster, and still need control. Things like, right, root access to VMs where the database run, sysdba access to the database. Those things are all available with the Exadata database service. And then we have the base database service. These are becoming available now in Multicloud as well. It's also a code managed service. So similar to the Exadata service, the real difference here is this is just the database put on more general purpose compute, general purpose infrastructure. Still provides cloud automation like the other services do, and the full administrative control. It just doesn't run on Exadata. Okay. So oftentimes I get, well, like compare. So, is looking at these different service offerings, we compare. We've got the database, if we were going to deploy this on, Azure Compute, on the Google Cloud, like Compute Engine or EC2, right? What does that look like? Well, the underlying infrastructure here, right, is provided to you as a service, but then everything there up, right, you would manage as the customer. When we look at these services that we can now offer in any of the different cloud providers, the Exadata or the co-managed services, right? Those don't just deliver the infrastructure, but also, being co-managed, we deliver automation through like a platform as a service, if you will. The responsibility model, because being co-managed, is still very, lots of these components are you as the customer's responsibility. But we provide all of the automation, the cloud tooling, the APIs that can be done all in an automated fashion, right? Or then the autonomous database where I mentioned, right, where Oracle runs and manages everything underlying, from the database, like the schema itself. Everything below that is managed by Oracle as a service, including things like your backups and restores, your patches, upgrades. Oracle takes care of all of that for you. I guess I'll pause here. Any question on the different services that are made available here, or the difference between them? And yeah, I see someone posted in the chat here with the multi-cloud capabilities app. Yep, definitely a good. Not only is that app that was posted in the chat helpful to see what services are available, this also is helpful to see the different regions and other things that are available too. So thanks for posting that. All right, so let's jump into a few of the use cases. All right, so as we work with customers, we're seeing three primary kind of use cases or drivers into bringing these workloads into the different cloud providers. The first, and usually where things will start off, is just moving to cloud, right? Many organizations likely yours included, have various initiatives on moving to cloud, on data center exits, for a variety of different reasons. But that kind of idea where you're lift and shifting an existing workload into a cloud provider has been something that, unless you are going to bring that workload into OCI, into Oracle Cloud Infrastructure, often created challenges, right? Because you were limited in the ability of where you could really go. Like I mentioned, AWS had RDS, so that helped a little. But even then, right, things like RAC weren't available there. If your workloads were definitely running on Exadata or other, right, high performance compute, there could be a challenge with scale, you know, for large databases, or performance and driving down the lower latencies that maybe a lot of these mission critical workloads that were sitting on premise required. So this is where this, you know, service comes into play, and being able to migrate those workloads into an Oracle database service like the Exadata service, or even in some extent, you know, the base database service can help alleviate those challenges. Also provides different consolidation opportunities to really bring down that TCO, and we'll kind of get into a little bit more of those details, but that's definitely where we see a lot of customers start. And the second one is some of the innovation that you can do on your applications. We'll talk a little bit more about this, but this is where a lot of things, and maybe autonomous database comes into this, but being able to leverage things around the different AI services and connecting those to the business data. So we talk about AI services from the different cloud providers, as well as AI services that are built into the Oracle database, especially with the new release of 23 AI and a lot of the integrated Gen AI type services, vector database, things like Select AI, being able to bring that, and then also co-locate that and integrate directly with some of the foundational models or other AI services within Google or Azure or AWS. The last one then, well, and I guess I'd also mention on the innovative, right, application, we talk about this, and this one is, you know, it comes into play for maybe new development workloads, right, where potentially if you were using, you know, a cloud provider, not OCI, the Oracle database definitely was lost as really a viable option for new workloads for a variety of reasons, but namely because it wasn't offered as a true service, right? Database as a service within those clouds. And so this kind of brings that option back onto the table, and there's a lot of advantages that we won't talk about in this, but around things around our strategy on converged database, and like I mentioned, some of the AI features they're building into these databases that can really help with those new workloads. And then the last one that's important for any use case where you're driving, you know, or migrating or building a cloud, is to reduce the complexity and cost. And quite honestly, if you were using Oracle database and the Oracle database workloads, and you were trying to do it in these other cloud providers, there was definitely a level of complexity that created friction to be able to move those workloads or build on top of an Oracle database. So this this solution reduces those. We'll talk a little bit more about some of the economic advantages here in a second. So let's dive into a little bit of these. And so the move to cloud, right? So with this, you know, several different things, but, you know, we talk about simplicity. So migration, right, becomes key when we're talking about lift and shift type scenarios, and making available things like our zero downtime migration tool that can be used across any one of these cloud providers helps, you know, orchestrating and automating some of the, you know, the tools that you're used to with migrating databases. Things around like Oracle Data Guard, for example, can be orchestrated and to help simplify, especially if you have a large number of different databases or workloads that you're trying to move, and that can be done that. And then, you know, one of the other key things here is, right, you can lift and shift, move these workloads without replatforming, right? So no replatforming onto another database, no replatforming even needed, right, with the Oracle database, because the same Oracle database on-prem is the database that you're going to be running in the cloud. So next here, the scalability. I'd kind of talked about this before. This becomes a key differentiator around things like comparing even with RDS, and not even just running Oracle on compute within these other providers, but something like an RDS solution as well, with the Oracle database services that you have available in the cloud providers. One, right, you have like full access to Oracle RAC from a high availability standpoint, as well as being able to scale. Scale as big as you're going to need any single database, thousands of CPU cores, as well as petabytes of storage that you can scale these workloads up to. The performance, we talked a little bit about that as well. Exadata is very unique in its performance aspect, right? For a few different reasons, including the I/O latency that it can drive, right, down to 14 microseconds, over 6 terabytes a second of scans for analytic AI workloads that become important. And in addition to that, right, would be the Exadata software. Like the fastest I/O is the I/O that you don't even need to do, and that's where Exadata really makes a lot of its gives its bang for its buck, right? Is the fact that you can eliminate a lot of the I/O that even needs to happen in the database with the storage cell software, and eliminating a lot of the I/O that even needs to take place. The availability then as well. We've talked a lot about this. I mentioned the other customer that I've been working with that I was just meeting with yesterday. This inability to run Oracle RAC, or to be able to have DataGuard kind of offered as a service, was really prohibitive them in Azure. But now is something with the Oracle database at Azure that they have fully available to them. It allows them to simplify and greatly scale down the different, the infrastructure and the pieces that they were trying to manage, and now manage all of that as a service, with online scaling, online patching, automated data guard, all of the benefits that you get these. The resiliency here, right? Everything's encrypted, by the service by default. Things being able to provision some of the things that I mentioned around the HA&DR, the RAC, right? Data guard, all of these can be provisioned directly by the cloud automation, right? Removing a lot of that complexity, but still being able to provide the HA&DR capabilities that you need. And then, the cost optimization. We'll talk a little bit about the cost benefits, but one of those benefits is just being able to use the capacity on demand and the scaling on demand, right? That dynamic scaling where you only need to provision the infrastructure and scale the workloads as you need them, right? And not needing to over provision on hardware. All right. Now we kind of get into that idea of building, right? So these are the advantages for building applications with these services. So one of the things, like I mentioned, is now being able to collocate those apps and that data, right? So now the database for Oracle databases can run directly inside of the cloud provider, offering between that application, and we'll talk a little bit about the architecture in a second, but the application and the database, right? You can expect up to sub-millisecond, right, latency between the application and database workloads. I talked a little bit about this whole idea with AI and the business data together, but lots of capabilities here, right? So, every organization is looking how they can continue to innovate around AI, and including a lot, obviously, around the generative AI workloads. This is one of the areas, right, that can really be helped with the Oracle database. Things in 23 AI around the select AI capabilities, the things with around vector use cases for like RAG-based workloads, and generative AI use cases. But the other thing, we won't have time to talk about here, but those of you that maybe are looking into that's native interface for SQL, right, with AI, with some of these foundational models and LLMs, and being able to use SQL in that context. Oracle's also released an MCP, so there's a new protocol, model context protocol, that was released by Anthropic last year. We have those engines built in now to the Oracle database, and you can interact with your LLM for choice and being able to just through natural language, right, being able to issue the different queries and create the SQL and everything that you need to. So now business users can easily interact with the database on an ad hoc basis, right, to be able to perform a lot of this analysis. And so some very cool things that we can get into. We won't, dive into that today, but things with being able to bring these workloads into these providers. So I do see a comment in the chat here. DataGuard now available on database at Azure. Yes, definitely. So DataGuard can be used in a number of different scenarios within database at Azure and Google Cloud and AWS, including things like cross-AZ, cross-region workloads. So, yep. All right. Being able to, again, kind of that whole any data workloads are, if you haven't heard and talked with about the converged Oracle database capabilities, definitely encourage, reach out to your account teams. And there's a lot of advantages with being able to use a single database for a variety of different workloads, right? Be those microservice workloads that are, using things like, Mongo APIs, document databases, maybe other workloads using graph type capability. These can all be done within the single database, and that's kind of around our converged database story. But these make, bringing the Oracle database into these cloud providers definitely makes that type of thing a possibility. Again, back into the performance, the throughput, and the transactions, that can be offered among these services also can be a differentiator. And then lastly, here on the use cases, talking about reducing complexity and cost. This is a key topic as you're evaluating any solution. And, a couple of a few key points here. One is leveraging, your investment with Oracle. So one is, you can, if you already have those licenses and that that you've purchased, you can bring those licenses now to what you're using with any of these cloud providers without penalty. In addition, you'll qualify just like you would with OCI. You qualify for what's called Oracle Support Rewards, so which can let you earn up to 33% of money back off of your Oracle support bill. I know every customer is looking and interested in lowering their Oracle support bill if you own Oracle licenses. So definitely key there. I mentioned with the autonomous database, the reduced administration, right, by having the majority of that database managed for you, can definitely reduce the overhead of the database administration. The hyperscaler commitments, right? So your Mac that you have with Azure or your Google Cloud commits, or AWS commitments, right? These services draw down from those commitments, right? So you'll deploy these through the hyperscalers marketplace, and being able to draw down the commitments that you've got on a single bill. The license costs, right? So if you're familiar with the licensing kind of requirements around deploying the Oracle database and these other cloud providers, the Oracle database at Azure, GCP, AWS qualify you for the reduced, right, covering the cores, and the license impacts as there reduces the database license requirements for deploying within those cloud environments. So definitely can have a big impact on the amount that you need to pay for licenses. We get around the scaling that's available, especially with the autonomous database, with some of the online scaling, right? The automatic scaling, the elastic pools can definitely help, for only paying again for the actual usage required, and not needing to over provision. And then lastly, we kind of mentioned some of the AI capabilities, but those that come with 23 AI, right? 23 AI right now is available on these services, and is still waiting to be released, to be deployed on other, like on just within the Oracle database, and if you were going to run it on compute. So you have some early access to features and things by deploying on these. Okay, that kind of the different use cases. Maybe I'll pause here again. I'm not sure if I missed any other questions or if anybody has any. All right.
Jesse,
Yes.
can you explain a little bit further on the converged database feature? Is it same Oracle database or with different features, or what it is?
Yeah. Yeah, Sudhir. And I don't have things that as far as going deeply into this, but essentially, right, the whole converged database concept with Oracle is the fact that, any different it becomes multimodal. So the different workload types that you have around maybe a document database, right, with JSON, or graph databases you needed, or relational, right, and table-based workloads. Traditionally, what the cloud has brought is, very specialized database services for each of these different types of workloads, right? And when you deploy your workloads in the cloud, you'll often go, right, you'll grab your database you're going to use for analytics, or more, the traditional data warehousing workloads, or those things, or some of the things that maybe you're doing with AI. Even you'll have a certain set of databases used for that. Then maybe, for your document storage in your databases, be it Mongo or otherwise, right? You'll have your different databases that and each cloud provider will have theirs, right? For those graph, you'll have a separate database. The idea behind the converged database is all of these different workloads can be, utilize one single database. And it's actually, and we have things around 23 AI that make this even more beneficial, right? Where we have what we call duality, like JSON duality, or the duality views for graph, where it's actually under the covers, right? It stores things in multiple formats, so that you can use with just, still the same data, right? You're not having to replicate necessarily data or these things, but you get the views in, as a document or as a graph or as a table, to be able to accommodate, right, what you need. And this is kind of where we come around, like what converged database means.
I got it. Rather than different types of databases, Oracle can work to accommodate all different type of loads, right?
Right. And so now you're managing, administering, and even utilizing from your applications, right? One database, and still, instead of having to build those integrations or administer and manage, right, multiple different database solutions and services, right? You can do that all in one. So. And definitely, what I would encourage, if there's interest in that, reach out to us. We can definitely connect you with the different enterprise architects that we have in our teams, and kind of get in, much more depth around use cases and things that may benefit you around converged database. I think the main point here for this session on the multi-cloud is just recognizing, right, that we bring those capabilities now into any cloud provider, right? The same ones you would get. So you're not just limited to being able to deploy and do some of these things within just OCI, but you can do it in the provider of your choice.
So is the Exadata and Autonomous only available at this time, or the base DB also available?
Yeah, so good question. Yeah, so we definitely started in multi-cloud with the Exadata and the autonomous services. The base database service is in a limited availability preview for in both Azure and Google Cloud. So if you're interested in those cloud providers, we're hoping at some point to be able to make that available in AWS as well. But if you have interest there, and we can definitely make that available to you in Azure and Google.
Thank you.
Hey, Kasey, is the autonomous database on other clouds, is it a dedicated or shared?
So good question. So those of you that are familiar with our autonomous database service, right? We have both a shared like deployment option as well as dedicated. Really where that depends, right, is whether you need dedicated hardware, you want that dedicated hardware, or more shared infrastructure. And it does vary a little bit by cloud providers. So currently the autonomous database shared is what is provided within Google Cloud and Azure, and Microsoft Azure. Autonomous dedicated is what's available within AWS. What I would say is, let's talk about the use case and different things that you may be, interested in. And we're definitely always in conversations with each of these partners, these cloud provider partners, and we definitely have roadmap to be able to offer both dedicated and shared in all three. A lot of influencing that roadmap and the priorities around that, comes to demand and the use cases and what customers want to do that. So
Thank you.
we definitely be interested in talking more.
Thank you, Kasey. And one more question. So in the one of the architecture diagrams, so interconnect, two of the options are interconnect and just cloud at customer or database at customer's cloud, right? Or Azure, Azure or AWS. So how does it work in terms of latency or connectivity? Are there any concerns from the latency standpoint if, let's say, a customer uses only the interconnect versus having a DB at Azure?
Yeah, no, good question. In fact, then my next topic here was going to be talking about some of the architectures here. One of the things, I'll say, so a couple things on that point, right? One is and one of the driving reasons why we first started with database at Azure here, we had the interconnect and we had some services where we even had automated and helped kind of deploying the database inside of Azure over that interconnect. But definitely most workloads, even though there was a strong backbone between our, the OCI region and the Azure region, you're still tying, because you are crossing, right, cloud providers and regions, even if they're somewhat close, I mean, you're still talking about, some milliseconds of latency, usually at, 2 at least. And it just depended kind of on the use case, what that latency was, but at least 2 milliseconds or more. That may work for, integrations, even that are tightly coupled. But if you have a highly transactional workload, right, likely even milliseconds like that, a couple milliseconds of latency can become too much. And so that's part of the reason why, we look at this architecture. So this is Oracle Database at Azure, right? And what you'll notice here is that we deploy this, and like the database itself goes into what we call an OCI child site, right? So this is where that database, so this gives an example just of the Exadata service, right? Autonomous is similar, but that's sitting inside of the Azure data center, inside the Azure region, where we directly connect, and this is made available inside of the Azure VNet through what's called a delegated subnet, right? So you deploy a specific subnet that you delegate to the service, and that way it presents as the virtual NICs, the VNICs inside of that subnet, and so that your applications or other services can connect, directly to that. And this latency becomes, sub-millisecond here, right? When you're talking about the VNet inside of, talking about the app inside of the same VNet here with the database, definitely you're getting low sub-millisecond type latency.
Right.
Does that help?
Yeah. Thank you,
Okay.
Kasey. Yeah, and if you could share, if there is any information, use cases in terms of, let's say, customer comes down to choosing interconnect versus database at the cloud provider, probably, comparison from the integration, networking standpoint versus the real benefit having the cloud, database itself in their cloud, right? If you have any use cases, please do share.
Yeah, and so I think we'll just simplify this for you. If you're talking about the application, like a workload running and needing to live inside of Azure, then database at Azure is your solution, right? For running that Oracle database with that, so that you can co-locate the apps in the database. And quite honestly, we would always recommend that, right? If it's now, the interconnect still can come into play for integration type use cases. You have workloads running in OCI, you have other workloads running in Azure, right? And they need to integrate. And the interconnect becomes a great way to be able to interconnect or be able to integrate those right through that interconnect.
Makes sense. Thanks, Kasey.
Yep. Other questions? It's good. I like the questions. We can.
So there is one question about when is 23A going to be generally available?
Oh, okay. Yeah, generally available, yeah, like on premise or another thing. So I do not have the answer to that. Definitely we can reach out, like, reach out to your account teams and with the product organization. I know it's coming. I honestly don't know if we've even published a target date, and unless any of the other Oracle folks on the call know differently.
Yeah, so Kasey, the push is more like 23 AI cloud first, right? So
Right.
that's the push in general. Yeah.
Correct. So I know it will be made available, but I don't have specific targets and timelines.
Actually, Casey, maybe the question is, can we be hopeful at all, or we just
Yes,
think?
definitely. 23 AI will be made generally available even, for on-premise or running it on compute workloads. I think, I mean, but I will say going forward, you can definitely expect this, right? Where new releases will be made available on the cloud services first, and the rest of the on-premise will come at a later date.
It's sometime in 2025, but yeah, we don't have the. But I think Kasey, on Exadata and ODA on-prem, we have it available. Just that non-engineered machines, it's not there, right?
That may be true.
Yeah.
I will admit, although I used to do lots on on-premise workloads, my life now is cloud. So
Yeah, that's correct. It's available in Exa, but not GA for the on-prem for non-Exa environments.
yeah, but definitely it will become available. That much I can assure. Just don't know at this point that our database product teams have made an announcement on exact timelines. So. All right. Okay, so as we talk about architecture, I know we kind of jumped ahead and talked a little bit about the architecture, how this is deployed in Azure. But I do want to just take a little bit of a step back here and talk about a fundamental concept, kind of understanding the architecture, because this comes up as I talk with any customer, right? So again, we talked about the multi-cloud solution of this and the fact that we've taken a little bit of OCI and embedded it inside of the other cloud providers. And so with that, right, what you'll notice with this solution, and the way we're able to actually give an actual OCI database service, right, inside of these, is we've taken the data plane, right, so the infrastructure there itself, like the Exadata, for example, and the databases that run on them, they're inside of that hyperscaler region, right? So they're inside of Azure or Google Cloud or AWS and co-located in those data centers. That said, the control plane still sits inside the OCI region, right? So it's still an OCI service, right? Still managed from that control plane. Now, as we kind of get in it, and I'll jump over because I want to be able to show you like the console experience a little bit of how this looks. You'll notice there's definitely the aspect where you still will navigate through like the Azure or AWS console. And you'll be able to deploy things like the Exadata environments or the autonomous databases from there. So there is definitely like integration where you have that console and the cloud providers, the API experience, but it's still ultimately underneath the covers, it's hitting that OCI control plane. You'll notice other aspects where you actually go into OCI itself and the OCI APIs to do some of the management, the deeper level management activities and stuff for that service. So you'll see this, as we look at the architecture here as well. But there are definitely both aspects. Be assured that your data and everything is inside the hyperscaler, but do understand there is a control plane aspect still with OCI. All right, so as we kind of look at the architectures, I'll start here with AWS. At a high level, kind of at simplistic level, the way this is deployed is, right, we take the Exadata or the autonomous services and deploy those inside of AWS, inside of like that child site that I mentioned, right? And there is a construct for the networking called an ODB network. So that's something that we deployed and worked on with AWS. And essentially what that allows us to do is to integrate directly inside of an AWS VPC, right? So these are tied directly and peered directly. We won't get into the details here of the different, multi-VPC and transit gateway and all of the different architectures. And definitely we can solve for those, but its most simplistic form, right? That ODB network is tied directly to a VPC. And in that VPC, you can obviously deploy your applications, or through different transit VPC architectures. You can also tie out to applications and other VPCs. On the other end, right, we do have still, like I said, the control plane and the OCI region comes into play there. This backbone, this OCI managed network, it is a backbone, right? A network backbone. You can, it's very similar to the backbones offered by every cloud provider between their availability zones, right? Or in OCI, we call them availability domains. So fully managed here by Oracle, and it links that child site with that OCI region for that control plane. Or if you have need of doing other things within OCI, you can do that, and that would come across that backbone, right? So I get often asked, like, is the interconnect involved? This is not the interconnect, right? The interconnect would be managed by you, the customer. You would deploy that. This is all managed by, that connectivity there is all managed by Oracle.
Yeah, I think, Kasey, that's where I wanted to you to highlight about this. Many people will, like, if they're multitasking, think this is like interconnect, but this is like between two availability zones, right? So
correct. So the dark fiber that we lay down between those, and the redundancy and the speed, it is very similar to what would be done when we connect our availability domains, or what like Azure, AWS, what they do when they connect their availability zones, right? So you can think of it in a very similar nature. Yep, that's right.
yeah, thank you.
Okay. And I'll try, and because I do want to jump over and be able to still have time to kind of show some things in the console, move a little bit faster here. This just gets into a little bit more detailed architecture, still inside of a single AZ. Outside the scope of this presentation, but we'd love to be able to talk with you more if needed to kind of get into multi-AZ, multi-region architectures as well. But again, we kind of talk about that ODB network. Inside of that ODB network, there are the logical constructs that are provisioned on the OCI side, right? So VCN, that's an OCI, like a virtual cloud network in OCI that kind of spans that child site, right? Inside that ODB network, as well as in the OCI region. And there's a couple of purposes and reasons for that. Depending on what you deploy, like I mentioned, your databases are sitting inside of AWS. You may have specific use cases where you want to use backup services, or even vault services, or other things in AWS, and you can do that because, again, you're still an OCI service, and there is that linked integration from those OCI constructs, right? And you'd be able to reach out to those services as well. So there are some things, like I mentioned, so automatic backups, right? You can take to S3. You can also take to object storage. You could also take to our recovery service, our autonomous recovery service. So there's different options that are available from a backup perspective as well. Things like monitoring come through like CloudWatch, like events come into EventBridge. So there's definitely some tight integrations on the AWS side through that deployment. Moving on to like Google Cloud, again, kind of at its simplistic architecture, we deploy with inside the Google Cloud region tied directly into a VPC, and kind of building out on that as well. We have similar constructs to what you saw with AWS, with what we call an ODB network that lives inside that child site right now here, just on the Google Cloud side. And allowing that direct connectivity between that ODB network and then inside a specific Google Cloud VPC. One thing, that's not available in AWS today, but we have within Google Cloud and Azure, right, is the ability to take those automatic backups to the OCI recovery service, the autonomous recovery service that lives inside of the Google Cloud region, right, inside that child side as well. So you have options, you know, to locate your backups there inside of the Google Cloud, or to even run those backups back into OCI if you so chose. So.
And this is same as ZDLRA, and there are different names, right, Kasey? We call this.
Yeah, so similar to the Exadata cloud service or the Exadata database service, right? Being a cloud service built on top of the Exadata infrastructure, the autonomous recovery service is a backup service that's built on top of the ZDLRA infrastructure, right? One of the differences there, though, this is a fully managed service for backups, right? So you don't manage the underlying infrastructure at all. Really, it's very simple. You're just setting up backups on the database and pointing it to the recovery service, right? And then the backup and then the recovery is very automated, but you get all the benefits that you would if you're familiar with ZDLRA. You get all the benefits, but it's just provided as a service.
And it's a one-click backup and restore kind of service.
Yeah. So once the recovery service is deployed and configured, then yeah, all you're doing is just pointing your database, the backups to it. Yep. It's very simple.
Is there any separate cost here, Kasey, for ZDLRA? I mean, object storage we have, right? But is there a cost associated with ZDLRA?
Yeah. So backups, you know, whether it's to the recovery service or to object storage, you pay for the space, the storage space that you're using, right?
Okay.
One of the great things about the recovery service is that the cost is on parity, right, with object storage. So you're going to pay essentially the same cost. Lots of great benefits though, if you use the recovery service, that don't come with backups. Things around like, you know, those immutable backups, right, for ransomware protection. Things like the incremental forever backups and stuff that can really change the game related, not just the backup overhead, but also like the restore performance and things that way, right? Where it's incremental forever. So no longer do you have to take full backups day in. So there's some unique technology that makes some of this possible. So the recovery service.
And we recommend customers ARS or ZDLRA, however we call it, right?
Yeah, I definitely recommend everybody use the recovery service. Not why, but we won't get into more of the details there, but definitely it's there.
So one question, Kasey, this is Santosh again. So the GCP or AWS has a solution to back up into the local storage in AWS, and I see in GCP you're providing the ARS service. Is it the same across Azure too, or can they back up to the local storage on the respective clouds?
Yeah, so you mean like a local object storage, right? So yeah,
Right.
so you saw that in AWS, right? Where we, yeah, and for AWS, you can take your backups, your automatic backups directly to S3. For GCP and Azure, you know, we are looking to do that integration. It's not available yet, right? To take it into the Azure Blob Storage, for example, or the object storage in Google Cloud. So something that will probably be available in the future. And we can kind of talk about that. That said, like I mentioned before, the recovery service is essentially priced, right? It's priced at the same kind of cost as object storage, with a lot of different benefits. So I think this, you know, for each different use case and workload, and we can talk about, but in general, with very few exceptions, I think recovery service is definitely the recommended route for where you keep your backups. And if it's, you know, if the requirement is storing my backups in the same cloud provider as the database, that is available, right, with the recovery service for both Azure and Google Cloud.
Got it. Thank you.
All right. Here, I'm gonna.
We have two more questions in the chart.
Sure.
The first question is, key vault feature can multi-cloud can use respective service provider key or OCI key only?
Okay, good question. So yeah, so I mentioned that the databases are encrypted by default, right? That's using what in Oracle we call TDE, right? Transparent data encryption. To be able to do kind of a customer managed key or bring your own key use cases, we by default, I should say, like that key is managed. We call it Oracle managed keys. It uses the Oracle wallet, and that's kind of how the service is provisioned out of the box. That said, if you want to use a customer managed key or bring your own key capability, you can do that through a vault service. OCI Vault is available on all the cloud providers and can be used today for key management services inside of the cloud providers. We do have the integration with Azure Key Vault today, so you can use Azure Key Vault in Azure. There's still, on the roadmap and work is being done to be able to integrate that with AWS KMS and Google Cloud too, with the KMS and Google Cloud. So those are coming.
Next question is, will ODB network reside inside VPC? Or in other words, ODB network is a subset of main VPC, or is it completely separate?
Yeah, it's a good question. And you can kind of see that in here. So the ODB network is not the VPC, but it is kind of how Oracle, in this managed network by Oracle in this child site, it's how we do kind of draw that connectivity into the VPC. And this kind of applies in AWS as well. So when an ODB network is created, you will specify which VPC that's going to be linked to, right? You will also specify the subnets that are going to be used inside of that ODB network. So you can think of it as an extension kind of that VPC. Think of it as an extension. So you will have to separately allocate the subnets and create the ODB network resource. And those subnets, right, you'll need to pick IP address spaces that don't conflict, right, with the VPC itself. But you kind of think of that as that extension, but it's the way we are able to kind of link now directly inside of the VPC for that communication out to those VPC subnets and even other things like Google Cloud, like each one of these, the network architectures and topologies available will get a lot more detailed than this. We won't have time to cover all of that today, but things like shared VPC use cases can definitely be deployed within Google Cloud, where you would actually put, this VPC would be in what's called like a host project. And that ODB network becomes in that host project as well, but then you deploy your databases inside of a separate service project, right? And utilizing that shared VPC. So there's different topologies, and each cloud provider is a little different. But definitely, but ultimately, yes, the ODB network allows us to be able to deploy directly and extend directly the VPC of the cloud provider.
So from a customer standpoint, if I have to manage this ODB network, right? So do I log into the Google Cloud Console and do that? How do I have access to that?
Yeah. Well, since you asked, let's look. Because I did want to show, and we're kind of running out of time. So here's where I just need, give me 1 second. I'm gonna switch over here. So I know you mentioned Google Cloud. We can go to Google Cloud, but maybe I'll bring up AWS instead, just for timing here, if that's okay, because it's somewhat similar. The architectures, the ODB network, it's the same. Yeah. Let me just, sorry, trying to see where. So there's my Azure console, but trying to get to my Google. Here we go. All right. Let me just make sure I'm logged in here. So I'm going to log in. Can everybody still see my screen, hopefully?
Yeah, we can still see. Yeah.
Okay, perfect. So I am logging in here to my AWS environment. All right. So you can see I've logged into the console here and just gone into my Oracle database at AWS service. I'm going to go over here into the dashboard. So within here, right, like this dashboard, what you're going to see is, some of the services we've talked about, right? Our Exadata, our autonomous, and we see the ODB networks, right? So you mentioned the ODB network. So from the console perspective, this is what we'd go and create it. I see various ODB networks. I would create an ODB network, and some of those things that you'll notice that when I create that, I'll give that a name. I'm going to pick the AZ that this network's going to be created in, right? So I'm within a specific region here in US East right now, Northern Virginia. So I'd pick the AZ. I will need to then specify the subnet, right?
And this is the
CIDR
VPC
spaces.
subnet again, right? This is the VPC subnet.
So this is the ODB network subnets. So what you'll notice here then is I will specify the subnet CIDRs for the VPC network, and then this works a little bit differently between AWS and within GCP. And AWS, I would come over here to these ODB peering connections, and I will choose my ODB network and my VPC, right?
Okay.
That I'm peering here. And that way, then I'm directly peered. So once I've peered my ODB network with my VPC, now all the communication channels are open, where I have that direct connectivity and everything. Now, so it is a good point, right? Those and this is a key point. Like the CIDRs of the subnets and those CIDR right IP ranges are specific to the ODB network, and that's where the databases will be deployed, right? And those subnets, they are not subnets of the VPC. However, once you peer the two, you can think of the ODB network and those subnets are just an extension really of the VPC. And as long as you're in the same AZ and the same region, then you can also like the latency that you should expect can get down to like sub-millisecond latency between the two, right?
Yeah.
So, okay. Does that help?
Yeah, thank you so much.
And Google Cloud is similar. In fact, I could probably yeah, let me here. I've got Google open as long as I don't know if it timed out, but Google Cloud's similar where we would actually, so this is my Google Cloud console. Again, I'm just kind of in the console now in the Google Cloud. You see a lot of similarities, right? With the autonomous service, the Exadata service, and we do need to create these ODB networks. When I create those on the Google Cloud side, you'll see actually the very first thing I do here is associate it with a specific VPC.
So this
and then region, right? And then I'll create the network, but then I still need to come back and create, like if I go into any one of these ODB networks, I still like I do need to create the subnets, right? The subnets are created separately. In fact, if I come here, you'll see this one just has one subnet. You can create multiple, right? Just one client subnet, but the subnets are created as part of the ODB network in both, right? That's in both AWS and GCP, and it's kind of an extension then of the VPC.
So this ODB and exascale need to be in same VPC.
So yeah, so the ODB network. So you said, so the question, ODB network and exascale.
Yeah.
So exascale is one of the services. So exascale, which is it's available already in Azure, and it's in a kind of limited availability in Google. That is one of our Exadata database services, just on shared infrastructure instead of dedicated infrastructure, essentially, right? And so again, the clusters, the VM clusters on the exascale, whether the Exadata service, whether it's dedicated or exascale, they are deployed inside of an ODB network, right? Inside of the subnets, like the client and backup subnets in that ODB network. And and the ODB network is what is directly peered or tied to the VPC.
Right.
All right, good questions. All right, since I'm here, we've already kind of dove in a little bit. But I do just want, I mean, as we kind of switch between AWS and Google Cloud and Azure, as you can see, I mean, this is a very native experience. I'm switching over here to Azure right now, and like one of the services here now within Azure now is the Oracle Database at Azure service, which I can come into. And again, I have, right, the different services available with Autonomous Database, the Exadata Database service, or like I mentioned, the Exadata Database service on Exascale. But when I go like into these, I can see my databases. Like for the Autonomous, I can go ahead and create a new database. So from just experience, perspective, a lot of this you are sitting inside of the cloud providers console or cloud providers APIs, right? And that is the case for most of the initial deployment, both for for any of the services, Autonomous or Exadata. One thing I will mention, because I kind of talked about, and then I'm gonna, because I've already got it up, I'm going to go over to back into my AWS, because let's see, here we go. I mentioned as well that there's still an OCI component of this. Underneath it, right? All these interactions are still happening with the OCI control plane as well. And if I go into so I've got this infrastructure, an Exadata infrastructure deployed here. If I navigate in my AWS console to that infrastructure, I'll see the information, right? So I've deployed 2 actual physical database servers inside this infrastructure. I've created, a number of different VM clusters here. I can go and look at, each of the different VM clusters on AWS, since it's dedicated, right? The autonomous dedicated is available. I also have available autonomous VM clusters. But one of the things that you'll notice here as well is there's certain activities where I need to manage inside of OCI, and I can do that by going to the OCI resources, right? So this same infrastructure has an OCI side, and if I click on that deep link, and this is the case with any of the cloud providers, Azure, Google Cloud, or AWS, it will directly take me, right, for, in this case, that infrastructure resource now displayed in OCI, right? Same Exadata infrastructure, but certain management activities, things like scaling the infrastructure or the fine-grained, tuning around the maintenance, for example, or things of that nature, I will still manage within OCI. So in that context, right, this is how we're taking the OCI service, made it available on AWS, but it's still very seamless, right, in navigating back and forth between them, both aspects. All right. With that, I know we're about 4 minutes before our end time. Any additional questions? I hope this kind of gave you a little bit, made this come to life a little bit, and helped set the context of like why we've done this, and kind of what the service implies.
So Kasey, when does people need to go use the OCI endpoint or URLs?
Okay, so good question. Yeah, and so the documentation will kind of show and break out for each service kind of what is done with both, but at a high level and simplistically, the initial deployment and provisioning is done within the cloud providers. So within AWS, Azure, and Google Cloud. Many of the management aspects, right? So we talked about setting up backups, or if you're going to set up some of the data guard on your Exadata, or in the Exadata service itself, even the database deployment itself, right? Which is a little bit unique because you're deploying within a VM cluster, where autonomous you're just deploying an instance. Those things though then become things that you'll jump over into OCI. That said, one of the things we didn't really touch on, but there's federation, right? So we often will recommend there's an RBAC, like the role-based access control setup for each cloud provider, and the federation that can be available, and that way you have a seamless single sign-on experience between both the AWS or Azure or Google Cloud and the OCI interfaces. So basically, just like what I showed, right? When I come into now this VM cluster, and if I want to go manage this VM cluster in OCI, right? I see this link. I can go directly into OCI on this VM cluster and do whatever I need to in that console, right? Because I'm federated and have that single sign-on experience set up. Does that help?
Yeah, that helps. And any other questions, anyone?
And just an extension, right? Once you go into the OCI side, I think depending, I think Kasey, you were not able to share the Exadata and ADB, you really run short. But if depending on that, on the OCI end, basically the DBA work is what is done on the OCI side, right? The CDB, PDB creation, if it is Exadata DB or autonomous taking backups and all that. I think
yeah.
That slide you were not able to get because of the time. Yeah.
Yeah. So for example, here, right, I'm on an autonomous, VM cluster here. So on the autonomous dedicated even, right? So I'm here in OCI now that I jumped from AWS right into OCI. And this is where I would create, for example, my autonomous container databases, right, which is a construct just of autonomous dedicated. But within there, right, and I can also create my autonomous databases. So I would come into OCI and do that. So again, these databases actually reside and live on the infrastructure that's sitting in AWS. So again, this is control plane activity only, right? I'm using the control plane and the APIs or console here within OCI to manage the databases that are sitting in AWS.
All right. Kasey, thank you very much. It's very insightful and a great presentation. I definitely learned a lot how the internals of multi-cloud works. And I echo that all the participants must have benefited learning multi-cloud features. So I know because of time we did not deep dive, but it's very useful presentation that we can literally get the high level features of how multi-cloud works.
Yeah. And I guess in conclusion, I would just share, right? We have a team that actually I and Hema are a part of, right? That we call the Tiger team within Oracle. We work closely with your account teams, your Oracle account teams. So definitely reach out to your account team or reach out to me. I mean, if you want, reach out to me directly. I'm going to throw my email address right into the chat. But we would, yeah, be more than happy to dive deep, right? This becomes real when we match it to your use cases, and love to kind of dive deep. We didn't really cover much of the how today, but I'm sure everybody kind of gets interested in that as well. But we can like cover that for each of your use cases, and more than happy to engage in that journey with you.
Yes. And I just want to present some vote of thanks. I'd like to thank our board of directors. They are Arun Yadav, Hema Satpathy, Cody Fincher, and Keith Wilcox. So in the back end, all of them work together to bring all these kind of sessions. And one big announcement that we have is November 13th is our training day. Please block your calendar. That's happening in the Grapevine Convention Center. It's an in-person event. We have multiple great speakers planned. So we hope to see you there. And for every audience, thank you for taking this time. And we're glad you're here. And we like to get engaged with you. So we are very active on LinkedIn. We are also active on the Discord channel. If you want to engage with us, please connect with us on those channels at least. And I see Kasey posted his contact details. If you have further questions, you can directly reach out to them. You can reach out with us also. But thank you and have a great rest of the evening. Thank you all.
Thanks, folks.
Thank you, Kasey. Thank you for taking the time. Thank you very much.
Pleasure.